Dear colleagues, let me introduce our work on topic the management of transport small river basins of Volyn Polissia, Buniv River case study. Today it is important to use methodological approaches to protect, preserve and restore the surface waters of the small river basins. From this position, we decided to devote our research to development of methodology elements of managing transformed basins of the small rivers of Volyn Polissia. To achieve this goal, we performed the following tasks: carried out on-site investigation and instrumental studies of the Buniv River basin, assessed the ecological stability of the landscape, determined the hydrological and morphological features of the river, assessed the quality of the river's surface water and bottom deposits, developed the management solution to achieve a good state of surface water quality. In our opinion, it is extremely important to develop and implement a joint program for rivers monitoring and to apply approved methodology for effective integrated water resource management of the transferred rivers of Volyn Polissia. This includes the assessment of the ecological state of river basins using GIS technologies, determining the environmental goals to achieve a good state of water quality, developing compensatory water protection measures, developing the design and estimate documentation if necessary, the organizational tools for addressing water users, all interested parties, state authorities and local self-government bodies, etc. Along with these important and topical issues is the need to ensure the flood safety of river and territories of the Polissia zone, as well as adapting to climate change. The flood safety of river and territories of the Polissia zone is exactly the problem that arose in the basin of small rivers in the areas of Volyn Polissia after the flood on May 17, 2019. The most affected locations were those belonging to the basin of the Buniv River. The Buniv River basin is typical for the bottom part of Volyn Polissia. There are a significant anthropogenic transformation of the natural landscapes. A significant part of the water courses of the Buniv River basin were once directed and transformed into main canals of the meliorative system. There is an increase in anthropogenic load on the river basin due to the overregulation of river flow, floodplain development, changes in morphological parameters, flooding of the territory, and so on. The changes in the structure and the water body's functioning parameters are a consequences of the manifestation of transformation and degradation processes that develop under the influence of natural and anthropogenic factors. These factors pose a danger of aquatic ecosystem, the population and engineering infrastructure in basin area. One of the main features of the Buniv River basin, like of the most small river, is the insufficient density of the monitoring system for registering extreme precipitation in its basin. After the destroying flood in 2019, we decided to investigate the real ecological state of the Buniv River and its basin. For this purpose, we used methods including on-site investigations, laboratory and analytical studies, data processing using GIS technologies, a topographic survey on the Buniv River floodplain within the most affected part of Rivne village. The on-site investigation included field surveys and water sampling at 4 control sites on the Buniv River for 13 quality indicators. A full-scale survey of individual sections of the river catchment area was carried out using an unnamed aerial vehicle. The chemical and analytical quality control of the Buniv River surface water was carried out according to regulatory requirements in the Certified Laboratory of Water Quality at the National University of Water and Environmental Engineering in Rivne City. The instrumental studies were determined as the sampling site using certified mobile devices. The mixed samples were used for the further laboratory study and clarification with a hydrological study of the bottom deposit composition. A total of 3 samples of bottom deposits in the Buniv River and 2 samples in the reservoirs were collected. The analysis of the constructed longitudinal profile along the river axis allowed dividing the study into 5 sections. The section of an investigated river basin differ by character of bottom deposit formation, by the shape of the river bed, carrying and transport capacity, by the hydraulic slope, etc. The fourth and fifth sections presented by reservoirs with the lack of proper regulation of water discharge affected the scale of flooding in Rivne during the flood on May 17, 2019. The impact of existing engineering infrastructure on the formation of flood zones. The maximum flow rate was calculated through the opening of the road bridge, indicated by the arrow in figure, for the flood conditions on May 17, 2019. This corresponds to a provision of 3%, that is, one time in 30 years. These floods can occur in the summer. The causes of flood are laying on uncontrolled and untreated surface runoff flows from the residential areas of the Buniv River and accordingly to the reservoirs in Rivne. Most often they are formed after heavy rains or during the melting of snow cover. A significant part of the household of Rivne are located in the floodplain of the river, in the zone of possible territorial flooding during floods and inundation. Such situation occurred on May 2019 as a result of great precipitation. There was a rapid rise in water levels, which led to the flooding of residential buildings, including the threat of the destruction of the pressure front structures at the recreational reservoir in the village of Rivne region. The heavy rain on May 16, 2019, which lasted about 10 hours, led to the flooding of 378 households located on the border territories of the Statnyk district in the Rivne region, as well as the different infrastructure facilities. The most affected locations were those belonging to the basin of the Buniv River. On these photos, we can see what damage was caused to the population and to the infrastructure of the region. On this slide, we presented the remote sensing data that illustrates how the water surface area of the Buniv River was changing during the 4 days from May 16 till May 19 in 2019, when the flood occurred. The analysis results of the chemical element content in the bottom deposits of the studied section indicated the presence of all studied elements. The source of anthropogenic entry of heavy metals into water bodies is primarily associated with road transport and wastewater, including natural causes such as the decomposition of dead hydrobiomes. On the diagram, we can see the difference between the results in 4 sample points. The content of heavy metals gradually decreases from first to fourth point. The surface water quality assessment shows that the overall ecological state of the surface water of the studied aquatic ecosystem is assessed as unsatisfactory. The block of trophoseparabilical indicators is dominant and determines the water quality. At the same time, its deviation from the environmental status is primarily caused by the biogenic elements of the nitrogen group and phosphates. Due to all above-mentioned factors and issues, the necessity of the improved monitoring system within the river basin is arising. The basic model of monitoring the condition of the Buniv River and its objectives can be presented by the steps on the slide. The introduction of public environmental monitoring can be a significant addition to the current system of water monitoring. This will increase the availability of environmental information for all stakeholders, quickly obtain the necessary data in the event of emergency accident, as well as current regular monitoring of the impact of water users on the ecological state of the rivers. Local public organizations in the framework of public monitoring should perform the following functions: monitoring objects that are not included in state monitoring programs, implementing environmental control and notification of accidents and emergencies, developing environmental education and awareness, evaluating the environmental impact of projects for plant activities within river basins, etc. For the effective management of rivers basins, it is necessary to create a basic council, the main task of which will be to develop, coordinate, and approve the river basin management plans. As a result of our research, we can propose such solutions for flood management and prevention of the damages such as occurred on May 2019. To develop and implement the river basin management plans, which include water protection measures. To develop and implement a joint program for public monitoring of the small rivers. To implement the following compensatory hydraulic measures, such as a periodic clearing of the riverbed section adjacent to the bridge from the deposits coming from the upper section, reducing the resistance of water flow at culverts and reservoirs, creating flood corridors, by arranging either appropriate cross regulators or laying pipeline structures that have a current capacity at a safe level for forgiveness flow rates. Two reservoirs, which are situated in the investigated part of Buniv Basin, require development regulatory rules that provide for the level of water response dependent on the current meteorological situation. Thus, if the amount of precipitation in 3 days reaches 20 millimeters, it is a signal to work with both reservoirs in order to overcome flooding. Thank you for your attention. And one of the things to remember, water resources are an integral part of the ecosystem and play a crucial role in the socio-ecological and economic development of territories.